Okay, you've continued on with your geometric sequences. You've made your t-tables and you have found the zero term for each of those geometric sequences. Make sure that you've checked with me before you moving on to making the graphs. I have two graphs that I'm going to show you. And what you're going to see is that the graphs for geometric sequences, they are different from arithmetic. Arithmetic sequences always formed a straight line. You're going to see with geometric sequences, that's not the case. What I have here is I have a t-table similar something to what you should have. It includes a zero term. And I'm showing over here that I was always multiplying by 3. So when you make your graph, you will need graph paper. You'll need to make an XY axis for each t-table. Like I have an XY axis here. And the next step then is to start plotting my points. So the first point I always want to plot is always the zero term. 0, 1. That's the first point here. So then I'm going to put that there, and I want to get a nice circle. So I want to have a dot here, and then I need another dot at 1, 3, and I need another dot at 2, 9. So let's see, 4, 5, 6, 7, 8, 9, and then I'm supposed to go 3, 27. Whoa, can't do that, can I? That's off my graph. So since it's off my graph, I'm only going to plot these 3 points. It gives me the idea of what we're looking for anyway. So take a look here now. I could actually go backwards beyond 0. So I'm going to start my line just outside this dot a little bit. And what you need to notice is that, what do you notice about this line? Is it straight? No, it's curved. It curves, it curves, it curves, and goes up like that. Okay, hard for me to draw it with the mouse, and I'm sorry it's not a very good line, but that's the idea, is you get a line that starts here and it curves. Okay, and I'm going to try to draw that line in there again so you can see how that curves again. So if you have a problem like this, sometimes it's a nice curve. There is another style of sequence graph, and I'll show you that in a second, but this is one where it curves like so. And I'm going right through my dot, and it keeps going up forever. 27 is off my graph. I don't have to do that. Just try to get a graph where you can definitely see the curve on it. If you get 3 or 4 points, that's great. All right, try to go be at least 3, because if you only have 2, you really don't get to see how that graph is curving. So make sure you have at least 3 points to make your graph. So this is one. Notice here all the numbers. When I'm always multiplying by a positive number. When you're multiplying by a positive number, you will get a graph that's going to curve like this. You also had geometric sequences like this one. And these graphs are quite a bit different from what you've seen. What you notice here, I want you to notice, this is when you are multiplying by a negative. So let's plot these points here, and they'll all fit on the graph that I have, and you'll get a good look at it. I think on a couple of the problems that you have, you'll only be able to get about 3 dots in before it really would go off your graph or off your paper. But this one gives you 5, and it should give you a good idea of what you're supposed to see when you do this. So the first dot I have to do is 0, and negative 1/2 is my zero term. So I'm going to have to kind of estimate where that's at, and I'm going to put that dot right there. The next one I have is 1, 1. So that goes right up here. The next dot that I have is 2, negative 2. So right 2, down 2, and plot that point. The next one I have is 3, 4. 3 and up 4. Goes right there. The last one I have is 4, negative 8. 1, 2, 3, 4, down 8. Looks like I got to scroll down here a little bit. And now we're at 8. Okay. If I was to do another one, notice it's timesing by negative 2. Now I would have to go all the way up to 16. And that's off my graph here. But this will give you a good idea how it works. So when you're multiplying by a negative here for a geometric sequence, let's draw in our lines. And this one actually is kind of a line. It won't actually curve. It does kind of go straight because I'm multiplying by a negative 2. And it goes like this. And then it goes down like this. And then it goes up like this. And then it goes down like this. Oops, looks like I got to scroll down here. Let's scroll down. Let me grab that first. Gotta extend that line. Here we go. And it goes down through here. Here to that dot. So take a look at this graph. Notice what it does. It bounces up, down, up, down. And that's because you're constantly multiplying by a negative. And notice the dots each time get a little bit further apart. So when you're multiplying by a negative on a geometric sequence graph, this is how it's going to look. When you multiply by positive, you're going to get a curve that goes like this. You're going to get this kind of a curve like that. All right, so now take those geometric sequences that you have, I believe there are 8 of them, and build a graph for all 8 of those. Be sure to show that to me when you get done, and then when you get done with that, you'll be writing the equations for those geometric sequences. All right, have at it.